In this video, we're going to learn how to evaluate functions using function notation, and we're going to focus on linear functions. Equations can be written in a form called function notation. We use this as a quick way to evaluate functions for a given input. So instead of writing y equals 2x minus 8 with function notation, we're going to write f of x equals 2x minus 8. So pretty much you can change y to be f of x. Notice how I read this. I did not read fx or f times x. We read this as f of x. To evaluate a function for a specific value, we're going to substitute this value or number in for x. So every time we are looking at an example and throughout this video, all we're going to really be doing is plugging in for x and following our order of operations. Number 1, we have f of x equals 3x minus 7. We want to evaluate f of 2. To evaluate f of 2 means we're going to take this 2 and plug it in or replace it where x is in this function. So instead of writing 3x minus 7, we're going to write 3 times 2 minus 7. 3 times 2 is 6. 6 minus 7 is negative 1. That's our answer. So if we evaluate f of 2, we get negative 1. Another way of writing this answer is f of 2 equals negative 1. This is your x value, this is your y value. Number 2, f of x equals negative 2x plus 10. Evaluate f of negative 4. Same thing. Wherever this is the x value of negative 4, so we're going to plug it in for x. So instead of writing 2x plus 10, we're going to write negative 2 times negative 4 plus 10 and evaluate it. Negative 4 times negative 2 is 8. 8 plus 10 is 18. Another way of writing our answer is f of negative 4 equals 18. This is our x value, this is our y value. Number 3, f of x equals 5x minus 1 and g of x equals 2x plus 3. Evaluate f of 2 minus g of 1. So first, let's just look at the f function. We're going to take this 2, this x value of 2, and plug it in for x. So instead of writing 5x minus 1, we're going to write 5 times 2 minus 1. 5 times 2 is 10. 10 minus 1 is 9. So f of 2 equals 9. G of 1. We are going to take this x value and plug it in for x in the g of x function. So instead of writing 2x plus 3, we're going to write 2 times 1 plus 3. So we're going to change that x to a 1. 2 times 1 is 2. 2 plus 3 is 5. Now it says evaluate f of 2 minus g of 1. Well, f of 2 is 9, and g of 1 is 5. And we just want to subtract those. 9 minus 5 is 4. Number 4, f of x equals 6x minus 4 and g of x equals x plus 4. What is the value of f of 4 divided by g of 1? All right, so f of 4, we're going to plug in 4 for x. So that gives us 6 times 4 minus 4. 6 times 4 is 24. Minus 4 is 20. Next 1 for g of 1, we're going to plug it into we're going to replace the x in the g of x function with a 1. So instead of writing x plus 4, we are going to write 1 plus 4, which is 5. Now what do we want to do with those? We want to take f of 4, which is 20, and divide it by g of 1, which is 5. So our answer is 4. 20 divided by 5 is 4. Number 5, if f of x equals negative 4x plus 18 and g of x equals x minus 9, evaluate f of 3 plus g of negative 2. All right, so to find f of 3, we're going to use this function, and we're going to replace 3 and x. So we'll do negative 4 times 3 plus 18. Negative 4 times 3 is negative 12, plus 18 is 6. Now for g of x, we are going to be plugging in -2. So we're, instead of writing x minus 9, we're going to write -2 minus 9. -2 minus 9 is -11. So we're going to take both of those values and evaluate the f of 3 plus g of -2. Well, f of 3 was 6, and then it says plus g of -2 is -11. 6 plus -11 is -5. That is our answer. Last example. Determine the value of k. So it tells us that f of 5 equals -12 and f of x equals -4x plus k. We want to find the value of k. Well, based on our function notation, we know that whatever we're plugging in the parentheses goes in place of x. So that's -4 times 5 plus k. And we know that equals -12. So now we just have to solve for k and simplify. -4 times 5 is -20. And to get k by itself, we need to move this -20 across the equal sign. So we are going to add 20 to both sides. So our answer is k equals -12 plus 20 is 8. Again, all we did for this problem is plug in -5 or +5 in for x, and we made sure that was equal to -12 to solve for